All right, 5, 4. It says graph the line, -1 over 4, y equals -1 over 4x. Remember, we need two things to graph a line. We need the slope and we need the starting point. Your slope is your constant of variation, which is -1 over 4. And your starting point is 0, 0, because there's no addition or subtraction. Remember, a negative slope, your line's going to end up going down from left to right. I'm asking you to have 3 points. So your starting point, 0, 0. And then use your slope to plot 2 more points. So -1/4 is down 1, right 4, because let's rise over run. And the opposite of down 1, right 4 is up 1, left 4. And that's your line. So you connect it through your graph. And it's going down just like we wanted to. It is not very steep because 1/4 is relatively small. The comparison of the rise to the run is not very big. So it's a relatively shallow line, but it is negative. And we're done. All right, we're going to continue direct variation. So yesterday we learned that the direct variation equation is y equals kx. Okay, we're going to use this over and over and over again today. So we learned y equals kx, and that is said that y varies directly with x because it's your constant of variation. So x and y are varied directly, and we're going to use that formula to fill in some pieces. So direct variation equation is what we're looking for. So the first thing you're going to do is going to plug in the given values for x and y. Your goal is to find your k, your constant of variation. And then you're going to rewrite it in the general form. So what this basically says is, if you're given x and y, that's a very specific point. You can't graph a line with just one point. So my goal is to be able to write an equation where I could then graph the line, okay, which is what we're looking for. In order to graph the line, I need my constant of variation to write my equation, and then I don't have to worry about the specific points x and y. So that's what I'm looking for. The general equation, when I ask you to write something in general, it's going to be able to be used more widely than just a specific point. So that's the goal, okay? So this says, they're all going to say this, right? A direct variation equation that relates x and y. So this tells you, suppose y varies directly with x. The second you read that, you write y equals kx, because that's what that means, okay? It fits this formula, y equals kx, if they vary directly, okay? They say that y is 28 when x is 7. That's 1 point. 728 doesn't give me a line. That one single point doesn't give me what I need to be able to graph it or to be able to use it to find other points or anything else like that. So my goal is to write a more general equation, but I know it fits this formula y equals kx, and I know one ordered pair. So all I'm doing is plugging them in. Y is 28 equals, I don't know k, but I do know that x is 7. So all I did was plug x and y in for the x and the y. All I'm doing is solving for k. K is being multiplied by 7. Opposite of multiplying by 7 is dividing by 7. So k equals 4. That's still not an equation that I can graph. My goal is to get a general equation, y equals kx, with a number for k. That's my end goal, because that's the one constant in the equation, the thing that's not going to change. So my general equation is y equals 4x. Now that's something I can graph. I know my slope is 4 over 1, and I know my starting point is 0, 0, and I can go from there. I can plug anything in for x, find the y. This is way more functional than just a single point. That's the goal. All right, so direct variation equation starts with, suppose that y varies directly with x. You read that and you automatically write y equals kx. Okay? Then you plug in what you know. Y is 27, x is 6, so I have 27 equals k times 6. To get it by itself, you're dividing by 6. So k equals 27 is not evenly divisible by 6, but we can reduce the fraction. They're both divisible by 3. So 27 divided by 3 is 9, and 6 divided by 3 is 2. Remember that the constant of variation is the same as your slope, and we want our slope in an improper fraction. You never want your slope as a mixed number or a decimal, so we need it as an improper fraction, 9 over 2. That's still not as useful to me as an equation, so I need my equation, y equals, my k is 9 over 2, x. Now this is something I can use all day long. I know my starting point, I know my slope, I can plug numbers in for x and solve for y and vice versa, and so it's much more useful. That's the goal. Done. Let's do this last one. Y varies directly with x, meaning y equals kx. Okay? Plug in what you know. It tells me that y is 10. I don't know k. X is 9. All I'm doing is dividing by 9. 10 is not divisible by 9, and 10 over 9 doesn't reduce. It's my slope, so I don't want to make an improper fraction, or I don't want to make a mixed number, so that's as far as that one's going to go. But I need my general equation that's more useful to me. So y equals 10/9 x. I know my slope, starting point, plug things in. That's a good equation, okay? Now, we're going to use it. So after you find your general equation, which is what we just did, we're going to plug in a new value and solve for the other one. So the whole point is to make something that's useful to us. And so now we're actually going to use them. So we already did this one. So 27 and 6. So I'm going to go up here and I'm going to grab it. When y was 27 and x was 6, this was my equation. So I'm just going to copy it and bring it down here. Okay? So that's my equation, but it says, write the direct variation equation that relates x and y. I did that. Then it says, then find x when y is 45. So now I'm not just having the equation, now I'm using the equation. So they give me y this time, so I'm going to plug it in. Y is 45 equals 9 over 2, and I do not know x. Okay, so x is being multiplied by 9 halves. The opposite of multiplying by 9 halves is dividing by 9 halves. So 45 divided by 9 over 2 is 10. So x is 10. So that's my point, like I'm using it now. So I had this equation and then I wanted to get an ordered pair when y was 45, and now I know that x is 10. So the point is 10, 45. So I could have that ordered pair on my graph if I wanted to. I could use it to answer word problems, whatever we need to do. But now it's more useful to us, and I know a complete point using that equation that I wrote. This one we did as well. So 10 and 9 was this one. Okay, already did it. Then it says, find x when y is 9. So now we're just plugging it in. So I know that y is 9, so 9 equals 10 over 9x. Okay, and it's being multiplied by 10/9, so I'm going to divide by 10/9, divide by 10/9. That's going to give me that x is 81 over 10, or 8.1. So that's my answer. And then the point, if I wanted to make an ordered pair that I could graph or answer a question with or whatever, x is 81 over 10 when y is 9. And that's it. All right. This one we haven't done, so we have to do all of it, okay? It says, write a direct variation equation that relates x and y and assume that y varies directly with x. So y varies directly with x means y equals kx. That's the first step. Then solve. So if y equals 7 or negative 7 when x equals negative 14. So that's my first grouping. That's all put together. So I plug it in. My y is negative 7. I don't know k. My x is negative 14. I'm solving for k, so I'm dividing both sides by negative 14. A negative 7 over a negative 14 is a positive 1/2. So my general equation, remember the general equation needs a number for k, is y equals 1/2 x. That's my equation. I can graph it, I can plot it, I can find other points, I can do all sorts of things. But they want me to specifically use it to find y when x is 20. So now I use it. I don't know y this time, 1/2. I do know that x is 20. So I'm just multiplying 1/2 and 20, which is 10. If I wanted a complete point, I plugged 20 in for x and I got 10 for y. So I found the k, wrote the general equation, used the general equation to find a specific point. Okay? So this format is what most of your homework is going to look like. You're going to write it and then use it on 5-4.